Dave Stallman here. We're doing more summation notation. Now I have two finite series here. One is an arithmetic series and one is a geometric series. And what I would like to do is represent both of them using summation notation. And so let's start by writing the explicit formula for the arithmetic series. And so the things that I notice are that the starting value is 10 and the common difference is 5. So with that information, we know for an arithmetic series that any term is equal to the starting value plus the common difference times n minus 1. Let's do the geometric series. We know that the starting value is 2, and now we have to find the common ratio. And so we have to figure out what is the number that we multiply 2 by to get 20. Now an easy way to figure out the common ratio is to take the second term divided by the first. 20 divided by 2 is 10. So the common ratio is 10. With that information, we know for a geometric sequence that the explicit equation is a sub n equals the starting value times the common ratio to the n minus 1 power. Alright, cool. So now we have explicit equations representing this sequence of numbers, and now we want to add them up because they're a series. And the way that we would represent that is for the arithmetic series, starting with the sigma sign, which means sum, or add these all up, and then we have to figure out which terms that we want to add. So we want to start with the first term, so that's 1, 2, 3, 4, 5. So we want to add up to the fifth term. And then we take the explicit equation and we write 10 plus 5 n minus 1. And so now we have represented this series of numbers using summation notation. Let's do the same thing with the geometric series. We start by writing the sigma to represent that we are going to sum or add all these numbers, and then we determine that we're starting with the first term and we're adding the first, second, third up through the fourth term, and the explicit equation that represents this series of numbers is 2 times 10 to the n minus 1. And so this is summation notation, which represents that series of numbers. Now, let's take a moment and do this backwards. Say, for example, that we didn't know what the series was. All we knew was that we had summation of first term to fifth term of 10 plus 5 n minus 1. And we wanted to add these all up. Well, what we would do is we would take the n values of 1, 2, 3, 4, and 5 and plug each one of them individually into this formula, get a number, and add them all up. So we would start by going 10 plus 5. You know what? I'm just going to write all these out. And I'm going to leave a blank spot for the n's. And we're going to have 5 of them. 1, 2, 3, 4, 5. Okay, so we have this equation 5 times. We're going to start with n equals 1, then 2, then 3, then 4, and lastly 5. And so what we would do is we would calculate each one of these and then add them all up. So let's see, that 0 times 5 is 0, plus that's 10, and then 1 times 5 is 5, plus that's 15, and then that's 2 times 5 is 10 plus 10 is 20. 4 minus 1 is 3 times 5 is 15, and 10 is 25. And then 5 minus 1 is 4 times 5 is 20, plus 10 is 30. And now we can add them all up. So 5, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we know that the sum of n equals 1 to 5 of 10 plus 5 n minus 1 is equal to 100. Now, let's do the same thing for our geometric series. Let's pretend that all we know is that we have a sigma with n equals 1 to 4 with this explicit equation 2 times 10 to the n minus 1. If this is all the information that we had, we would evaluate this by doing the following. We would want to take the numbers 1 through 4 and plug them into this equation, and then calculate each of those and add them all up. So let's see, I'm just going to write 2 times 10 to the something minus 1, 2 times 10 to the something minus 2, times 10 to the something, oops, call me silly. That should be a 1, minus 1, and 2 times 10 to the something minus 1. Okay, so we're going to start with n equals 1, and then n equals 2, and then n equals 3, and then n equals 4. That we're going to evaluate each one of those. So 10 to the 0 is 1, times 2 is 2. Let's see, 2 minus 1 is 1. 10 to the 1 is 10, times 2 is 20. Let's see, that's 3 minus 1 is 2. 10 to the 2 is 100. That's 200. And let's see, that's supposed to be 4 minus 1. So 10 to the third is 1,000 times 2. That's 2,000. And we add those all up, and it's 2, 2, 2, 2. So we would say the sum from n equals 1 to 4 of 2 times 10 to the n minus 1 is 2,222. And that's how that works.